Today's session, we're going to be focusing on learning about the differences between the use of wireless and wired network. We're also going to be looking at Bluetooth, we're going to be looking at Wi-Fi, we're going to be looking at different characteristics of copper cable, fiber optic, radio waves, microwaves, and satellites. So a lot of different types of technologies that help make a network come together. And perhaps you don't realize it, but you are using it every day when you're using the internet. You need to be aware of each type of connection method and their advantages and disadvantages so you can make the right choice when you're either making something or you're recommending it for a context or a customer or a client. Let's start by looking at the cables themselves. The first one that we're going to be looking at is the wired twisted pair cables. This is the most common form of cabling used in local area networks. It has quite low data transfer rates. It suffers quite a lot from external interference, but it's used a lot because it's cheap. It comes in two different types: unshielded, which obviously is more susceptible to interference, and that's normally used in the home. And then you have a shielded variety, which is used in commercial situations. So think about the school network, that's probably using a twisted pair cable, which is shielded. Now the cable itself has 4 pairs of twisted wire. The metal part is obviously the conductor, and you've got an insulator that protects it, and then there's a cable jacket outside it which is covering the whole sets of wires so they don't come loose. Next up is the coaxial cable. This is the most common type of cable used in metropolitan area networks, basically cities, and often by cable television companies. So if you've got a set-top box in your home or a cable box in your home, chances are this is the type of cable that is being utilized. It has a better data transfer rate and limited external interference. However, costs are much higher than twisted pair cable. It does have 80 times the transmission capacity compared to the twisted pair cable, and some of the best anti-jamming capabilities of all the cables that we're going to be discussing. It's basically a copper wire which has insulation and then a copper mesh around it to protect it from interference. And finally, you've got the outside jacket or outside insulation that protects the entire setup. The next cable on our list is the fiber optic cable. Now this enables long distance data transfer. It has some of the best data transfer rates. It has the best resistance to external interference. However, it's very expensive compared to the other two. Fiber optic, just as the name goes, with the word optics in it, it basically uses pulses of light rather than electricity. The other two cables that we discussed all work with electricity. This one works with pulses of light. It has 26,000 times the transmission capacity of a twisted pair cable, and it normally comes in 2 flavors. The first one is the single mode, where you have one light source, less reflection, so you have a longer range. And then you have multi-mode, where you get a lot more light sources, more reflections, and a bit of a shorter range. It's mostly used within local area network. Again, the setup is actually quite complicated. You've got the optical fibers, you've got the flexible buffer tube outside it, you've got water blocking binders, rip cords, strength yarns, and an overall jacket to protect it from breaking. Obviously the optical fiber is very fragile, so it can't be bent compared to a twisted pair or a coaxial cable. It's kept as straight as possible, and that's one of its disadvantage, because if you do bend the cable, your chances are your light is going to be reflected or refracted, and that's going to cause problems, especially with data collision. Now wires are fantastic. They're very secured. They don't have as much interference as wireless, but they can cause a lot of problems. Wires can be messy, and the more complicated your network is, the more wires you're going to end up using, and that means that somebody is going to be sitting there working out which cable goes where. And all of that causes a lot of headaches for people who manage the network, and this is where the Vikings came along, and they came with a technology called Bluetooth. And what they wanted to do was to simplify the way we communicate and share data in a shorter range. So Bluetooth came about, and just in case you're wondering what the Old Norse phrase is, it's I came, I saw, I conquered. And Bluetooth probably saying that I'm the king of wireless communication. But along comes Wi-Fi and says, wait, I was here first. If you wanted to kind of just find out why there's a link and there's the word dental problem there's actually a dental problem called Bluetooth. I just found it a bit funny that we use this word and dentists also use this word, but it has a different meaning for them. Now, Bluetooth was named after an old Viking king. Wi-Fi, unfortunately, was discovered by accident. Astronomers in Australia were looking for black holes, and during that particular process, they developed this particular technology. Isn't that interesting? Something that physicists were using to discover black holes ended up being the foundation of the internet. Now, both Wi-Fi and Bluetooth are technologies that use electromagnetic radiation to carry data. Both use something called spread spectrum technology, including frequency hopping, to avoid interference. Now, spread spectrum technology basically is spreading a lot of channels over a particular frequency, and frequency hopping is a technique that's used by both Bluetooth and Wi-Fi to avoid different devices connecting to each other on the same channel. What it basically means is that Bluetooth simply says, well, all right, I've got 79 channels around the 2.45 gigahertz range, whereas Wi-Fi has only 56. However, Wi-Fi can operate at two different sets of frequencies, 2.4 gigahertz and 5 gigahertz, and that allows it to both have speed and bandwidth and distance as well. So if you think about it, Bluetooth normally operates within the 30 meter range, whereas Wi-Fi can go all the way up to 100 meters, and the speeds are also significantly different. Now let's just look at Bluetooth and particularly what spread spectrum frequency hopping is all about. So Bluetooth devices automatically detect and connect to each other. They don't interfere with other devices which are using different channels. Remember, there are 79 channels. So if you have two sets of devices or three sets of devices in the same room using Bluetooth, then the first set will probably pick a channel and the second set will try a channel, and if it's the same as the first set, it randomly picks another one. So a device will pick on one channel, and if it's already being used, it randomly picks another one until it finds a new free one. This is actually called spread spectrum frequency hopping, and the devices constantly change channels they are using several times a second for privacy, and also use encryption for security, and that's very useful. So even though they picked one frequency, within a second they might change it 3 or 4 times just to make sure that nobody else can listen in and capture the data. Now, Wi-Fi also uses the same type of technology, but it's normally useful for full-scale networks because it offers faster transfer rates. It has better range, it has better security, and up to 100 meter distance compared to the less than 30 meters for Bluetooth. Normally Bluetooth operates in the 10 meter range, but you can probably get modern devices that can go up to 30 meters. And similarly, Wi-Fi is also increasing its range as technology improves. Now, wireless connectivity normally uses electromagnetic radiation. Things like radio waves, microwaves, or infrared are also part of this particular spectrum. Even though you don't need to do any calculations, it's useful to understand what the spectrum and the relationship between wavelength and frequency is about. So if you look across it, radio waves are normally operating in the 3 megahertz range, microwaves are in the 3 gigahertz range, and infrared is in the 300 gigahertz range. We don't use the visible light spectrum, and we don't use ultraviolet, X-rays and gamma rays for data transfer yet, because they can ionize skin and that can cause all sorts of issues. Now, the frequency is basically the speed of light divided by the wavelength, and you can check out by putting in the frequency and the speed of light, where you can work out what the wavelength is. Microwaves are normally used for Wi-Fi, that's the most common one, but radio waves are also utilized. What you do need to know is the comparison between different frequencies, and especially on the factors such as bandwidth, penetration and attenuation, which basically means the reduction of amplitude of a wave or a signal. In layman's terms, that basically means what's the likelihood of interference or a signal being stopped by walls. So if you're looking at bandwidth, infrared is greater than microwaves, which is greater than radio waves. So infrared has the largest bandwidth. Penetration, radio waves are greater than microwaves, which are greater than infrared. So radio waves have the best penetration, so they can pierce walls. And Signal loss, radio waves, microwaves, and infrared. So radio waves have the best attenuation. Now, if you were looking at one that fits everything, you'll probably see that microwaves are in the middle. And that's why we go with microwaves for both Bluetooth and Wi-Fi. However, both wired and wireless might not be effective all the time, because what if the distance you want to communicate is over 100 meters? And that's where satellites come into play. So normally what happens is that there's an antenna which is transmitting signals. So if you've got an antenna on one side of the planet and another on the other side, normally the curvature of the earth will stop the signal from getting through. However, if you do place a satellite in the earth's orbit, the antenna could send a signal to the satellite, which can then boost the signal and transmit it to the antenna on the other side of the world. And that's basically what the philosophy is. So if you're looking at the images, you'll probably see the very first Earth. The signal is going out into space. It does not reach Tower B. And in the second image, you'll probably see that a satellite is being used as a go-between both sets of antenna, and everything works. Now, satellites have an amazing range, and they can provide services to remote areas where normal cables or Wi-Fi or even Bluetooth or even mobile signals don't have the ability to reach. So let's now look at a comparison between wired and wireless. Do pause the video if you need to take these notes down. Wired tends to be reliable and stable. It has a faster data transfer rate. You don't get any dead zones where there's a signal loss. It's cheaper overall. However, the devices are not mobile, and lots of wires can lead to tripping hazards, overheating, and disconnection issues. Wireless, on the other hand, is easier to expand, gives you increased mobility, but you do get more interference, and it's often less secure with a slower data transmission rate. Even signals can be stopped by thick walls, which can have an impact on performance. Now that ends the lesson for today. Next lesson, we're going to be looking at the hardware used in networks. But at the end of this particular lesson, you should be able to tell what the three types of wires are which are used to build networks. You should be able to answer questions like which wire type has the best transmission rate, which is the cheapest, which is useful for metropolitan area networks, which one is useful for LANs. You should be able to answer questions about Bluetooth and Wi-Fi. What is spread spectrum hopping? You should be able to give at least 2 benefits of wired and 2 benefits of wireless, and equivalently disadvantages of each as well. That's all for me. I'll see you next week.